Hello atmospheric science students, Dr. Shragi here, and I'm here today to talk to you about that second reading from the In the Beginning Was the Command Line book written by Stephenson. And this reading kind of is just designed to kind of help you see a connection between the way you're connecting between your laptop or your PC or however you're doing it to a distant computer like Chesapeake, which is 600 miles from where you are right now. And to see that there's actually a long tradition of doing computing that way. It may not be the way you're used to doing your things day to day, like web browsing and writing your papers and stuff, but it's actually a really robust way of working with computers. And frankly, it's probably going to be an important way in which you're working with computers, you know, in some future job or whatever. But definitely, there's no doubt about it. That doing this reading reminds you that Stephenson is a really old guy. Well, he isn't really all that old. He's like 55 or something these days. But he is, he has a very long connection to computers. And he's talking about, like, as a teenager in Iowa, he was taking in his high school, he was taking computers classes, and they didn't physically have any computers. Rather, they were connecting to a server, a mainframe on Iowa State's campus. A mainframe is a different kind of computer than, say, Chesapeake is. Chesapeake is a Unix workstation. Mainframes ran different operating systems. They were those big, clunky, iron computers with vacuum tubes and stuff that you would have, even as late as maybe the early 90s, such things still were in use. Nowadays, mainframes don't really exist, but if you go on, and you listen to what Stephenson is describing here, where he was sitting at some kind of machine that had a keyboard and he was typing into it, but he was not physically in front of the mainframe. In fact, he wasn't even doing something on the mainframe at that time. The machine that he was entering his computer program in, he sat there and wrote the program out by hand first. Then when he had it working, he would sit there at that little machine and type it in. And it was producing, in his case, he was talking about paper tape, but I wanted to show you first punched cards. You've probably heard of punched cards as being a way of presenting data. You probably have never actually seen one or worked with them or anything like that, because why would you? But this was a way that for a very, very long time in computers, this is how we stored data, wrote programs, etc. A card, each column on the card represented, you could put holes in the card, and the combination of holes in the card there mapped to a code that, maybe a certain combination of holes punched out was the letter A, and a different combination of holes punched out meant the letter B, and so on. So an individual card could contain about one line of text. Okay, typically like a line of a computer program or something like that. And we'll see how that actually radiates down to the present time. So surprisingly much, actually, if you start looking at how C programs actually work. The computer's in many ways still thinking about punched cards. But a single card like the one you're seeing there on the screen might have stored the equivalent of like one line of text, where each column of the card, the combination of holes that were punched out, told the card reader, the machine that was doing the reading, what letter that referred to. So each column on the card was one letter, and since there's about 80 columns on the card, it could make about 80 letters. This was very old technology, even in like the 70s, when Stephenson is talking about. Punch cards were used for about 100 years before then. They were a Victorian technology that told simple steam-driven machines, things like the machines that wove fabrics during the Industrial Revolution. Punched cards would inform the machine how to move the different needles and so on to make different fabric patterns and so on. Punch cards was an old established technology even as computers were first getting started. The particular machines that Stephenson was talking about used paper tape. I actually never used, well actually I never used punch cards either. I saw punch cards in use but never did it. Paper tape I've never even seen. But you can kind of get the idea. It's the same sort of thing, except instead of it being one card being a line, it's just sort of a continuous long piece of tape that has punched holes in it. So as he sat at that machine and typed his program, it was punching holes in the paper tape, and then he could later feed the paper tape back through the machine to tell it about the program it's running. But no matter what, a program was more than one card or more than one piece of tape. Like if here I have a deck of these cards. A deck would be a whole set of cards that together made a program or a data set or something like that. And so just like, the web page that you're making or whatever, where, the file contains all the instructions, that deck of cards right there would contain the instructions to write a program, right? It would be a set of Fortran program or C program or something like that. And when you were ready to run the program on the mainframe, somebody physically carried your deck of cards over to the card reader. There's a picture of a card reader there, just so you can kind of picture what it is. They slid the drawer of cards into the machine, or a box of cards in the machine, and the machine could pick up each card, you know, with pins to determine which holes were punched and which weren't, and understood the instructions on the card. But this was not something you as the user did. You as the user submitted a job. You got on a list, and depending on your priority and how long you've been waiting, you got your job done. And this was even, gosh, when I was in grad school in the 90s, there were still computers that worked this way, where you wrote your program and then you submitted it to run. That's not the way our programs are going to work today. When we are working in this class, you're going to write your programs and then just run it right there and see if it worked. But that isn't the way it was done on these old, slow mainframes. So you would actually submit the job to the computer center, they would actually run it, and then typically the output of the job, like whatever it was supposed to print or whatever files it was supposed to create, would get literally put onto green bar paper. The world went through billions of tons of this stuff back in like the 70s and 80s, where the mainframe would print the results onto huge stacks of paper. And it was always this white and green bar paper like this. And you would print your job, and then sometimes they literally mailed it to you. More often than not, the computer center would like have a system of like mailboxes, and they would slip it into your mailbox because you were this user and you were that user. And then, you know, some number of hours after you submitted the job, you could go and pick up your output and look and say, oh, my program didn't work. And then start the whole process over of putting in your program again, submitting the job again, waiting for the output. It was a very, very slow process and very, very wasteful. The world went through just enormous stacks of these green bar papers and stuff, trying to figure out how to get past this kind of era in computing. But it is very related to what we do now, but we kind of had to get one step closer. The machines that were doing this business of taking our programs, you would type them in and it would make punch cards or it would make paper tape, were called teletypes. And somewhere around the late 70s, early 80s, they invented the so-called glass teletype, which came to be known as a terminal. Terminals did the same sort of thing, except you weren't actually filling out any paperwork, you weren't actually punching any cards or punching any holes in tape. It was done kind of in a virtual way. Now that machine that you're seeing there, that's actually a Zenith Z29 terminal. I actually did a lot of my thesis stuff on something that looked just like that. Admittedly, it was also like the late 90s. It was some piece of equipment that I probably could have done better than. That machine that you're seeing there is not a computer, okay? It is a machine that I am able to connect to the mainframe computer or a big Unix computer or something, and I can type in my instructions in there. And at least I'm not punching cards and punching tape. I can enter the commands and then I can run them interactively on the mainframe. I'm not waiting for a job to run or anything like that. And the output appears on the screen. I don't need to wait for it to be printed onto green bar paper and put in my mailbox. I can go and look at it. But there's a lot of connections between this terminal idea and what we're going to be doing in this class. I mean, for example, remember if I look back at this slide with those punched cards by definition had 80 columns in it. I don't know who decided 80, but they always had 80 columns. And if you actually took a look at the screen on a terminal, it had 80 columns too. There was always 80 columns wide. For all intents and purposes, each line on the screen of the terminal was one punched card. You know, you would put, now on the terminal, you're literally just typing on the screen there and putting letters in each, you know, those columns. You know, but it was, from the point of view of the mainframe, it was exactly the same thing. It was just a stream of characters, whether it was in the form of holes punched in a card or whether it was in the form of, you know, letters entered on a keyboard on a terminal, made no difference to the computer. There's a connection between this and what we're doing. Now, when you guys are connecting to Chesapeake, a very much more modern computer, you're using terminal software like PuTTY or what is actually uncreatively called terminal on a Mac, and it does the same thing. And by the way, when you first open that window, it has 80 columns in it. It'll be using a fixed width font with 80 columns across. That is still the definition. Although these days you can in fact use the mouse and resize that window, and that is an issue that has been resolved. It's no longer thinking in terms of punched cards on the other end. Chesapeake is not assuming you're talking about punched cards anymore. but it certainly would work. Now, we could be sitting at a computer lab full of terminals. Well, we could if they still existed, okay? But certainly as recently as maybe 10, 15 years ago, on campus there would have been a room where there was a bunch of these terminals. They're not computers, but they are places where you could be typing in your programs to be submitted to, in this case, Chesapeake. In fact, it would still work, okay? There's just no reason to have such things anymore. We have better, cheaper solutions now. We could certainly do that, but of course we tend to prefer to do something more like what you see here, where we are on a client computer, your Windows computer, your Mac, typically could be something else, Chrome or something like that, and you are running terminal software. Technically the right word is it's a terminal emulator. It is acting as if it's a terminal, but all it's really doing is providing you a connection to the other computer, in this case it's Chesapeake, and it is allowing you to enter keys, you know, tip, 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 as if you're in front of that machine, even though you're physically far away, in this case hundreds of miles away. All of which would have seemed astonishing to Stephenson back in like the 1970s, when he's sitting there with his old smash modem, trying to send his program that he's got there on a piece of program that he's trying to send over, you know, off of a piece of paper tape. But you know, that's the nature of technology. But in many ways, it's the same thing. In many ways, that terminal window or that PuTTY window that you're bringing up, or God forbid if you're using like Chrome SSH or Fire SSH or one of those solutions, all it really is doing is flinging bits, the individual characters that you're hitting on the keyboard, just flinging them across the cloud to Chesapeake, here in my office, and Chesapeake is doing stuff with them as if it's sitting there reading a stack of punched cards. Now in this module, you're going to be actually writing your very first C program. You're going to be using VI to create a something.c program that contains your code, the program that you're trying to write. You'll be compiling this program. That'll be your first experience with compiling using the compiler that we have installed. It's called GCC. There'll be more information later about what it means to compile and why you have to do that and so on. And then this may all seem really strange. It's all very far, it seems, from clicking and dragging and resizing windows and scrolling and stuff like that, because it kind of is. Because those are all just layers of metaphors that separate us from what the computer's really doing. Well, to some extent that's a really good thing, right? In many ways I don't want to know what my computer's really doing, I just want to get my work done. But there are ways in which times we do need to know how the computer is doing it. We need to be doing things like writing programs, okay? Most meteorology jobs involve working with computers, they involve working with programs, they involve modifying programs, they involve processing data and so on. You're probably not going to just be sitting there clicking on apps, okay? You're going to be tinkering with code and stuff like that. You need to get past, around all of that mouse stuff, all of that interface stuff, that's these layers and layers of metaphors like drop-down menus and so on. We'll be talking more about what metaphors mean and so on in a while. But you need to get around all that. And so that's kind of, we're just sort of getting our feet wet in this a little bit. We're going to be learning more and more about these layers of metaphors and how they, quote, mediate the experience in another lecture, where Stephenson spends more time on what that all really means. But for now, what I really want you to get is that sense of awe. That sense of you're a tourist. You're a tourist on Chesapeake right now. When you first land in a faraway city where you don't speak the language and stuff like that, you know what? At first, you're just in awe. You have no idea how to make sense of any of what you're seeing. The grocery stores are weird. What's that weird landmark? Why are they talking like this? Whoa, they drive on the other side of the street. Whatever. You're just gawking. And that's okay. That's actually part of the experience of travel, is the gawking part. Okay? Sometimes people make fun of tourists or something like that, you know, that like somehow or other they're not getting the right experience or something like that. No, that's part of the experience. But also part of the experience is gradually learning that there are reasons why things are done the way that other country does it or that other faraway place does it. And that a lot of it's just arbitrary. That you're just now seeing how what they do is just different. But they could have just as easily done it our way, or we could have done it their way. We're going to be learning that over the course of the semester, that a lot of this Linux stuff is just different. Okay? Some of it there's reasons for, some of it is just, it comes from a different tradition, and you're going to gradually no longer be a tourist on Chesapeake. With time, you're going to be like, I'm an old hat. Man, I'm like an expat now. I'm an expatriate. I have left my comfortable world of Mac OS or Windows or whatever, and I am now comfortable in the land of Linux. And that will make me very, very happy. All right. Go ahead and start moving your way through the next couple of assignments. This is an exciting unit, module, because you start actually doing programs. All right, let me know if you have any questions. This has been Dr. John Schrage.